Morning, guys.
Good morning.
Morning. Yeah, I don't know why this meeting has been changed so that it won't start without me joining the meeting.
Yeah, I just changed. I cannot join before you started.
Okay, let me see if I can fix that. Okay.
So we're still waiting, right?
Yeah, we're still waiting for a few folks to show up. Yeah, I think we can get started in a minute. Let's get started. Yeah, I need to fix the Zoom issue. I think that prevents people from joining before I join the meeting. There's some switch somewhere to figure out.
Oh yeah, I tried it.
Okay, so James, I think let's get started, and people might join later. Do you want to share the doc?
Yeah, let me do that.
Yeah, I've been hearing that a lot. So we're going to talk about this. This should be no big deal.
Okay, there it is. All right, can everybody see that?
Yeah.
Yep. Okay, so I started looking at user namespaces, and I haven't got to the point of actually defining in a concrete way what I think we should do in Mesos. But I have gone through it enough to try and understand what other systems do and to try and understand, what exactly are user namespaces and what are they good for. So that's what this doc is all about at the moment. We'll probably come back later and maybe add a few pages. And I have some ideas about how Mesos can leverage this stuff, but that's sort of a pretty hand-wavy.
Okay.
So there's really two parts to user namespaces. Mostly the part that people think about when they hear user namespaces is the ID mapping. But there's actually, it's sort of the most intrusive part, but not necessarily the most interesting part. The most interesting part is kind of the security mechanism and the security model that's around it. So you have two parts here, the doc, where we explain both of these, and maybe I have them here in the wrong order, but for understanding things. But so let's look at it in probably the right order. So I'm a bit surprised that they got this change into the kernel, because it's a pretty interesting but very, very intrusive change to the Unix security model. Basically, what a user namespace really is functionally is it's a scoping of privilege. So it's basically a each user namespace defines a security domain. And if we look at this diagram of kernel objects, we can see that user namespaces are organized in a tree. So we have a global variable init user ns, which is the initial user namespace, or what we call in the terminology the root namespace. And every time you create your own user namespace, it gets linked into the tree, and the root of the tree is this user ns. Also part of the tree are process credentials, so struct cred, and PIDs and other namespaces. So every time you create a namespace, it has a parent, which is a user namespace. Every time you create a cred, so every time you switch UIDs or you start a process has a credential. So every time you do anything like that, your PID and your cred is associated with the user namespace. So the user namespace is this scoping object. So basically, it's defining the security domain for the namespace and for your process.
So James, one question. What do you mean by the cred here? What is that?
That's struct cred.
What information does it contain?
So this is your process credential. So it's a kernel object here that holds the identity in the security context of a system process.
Oh.
So when you do a set UID, you're manipulating the content of a struct cred.
Oh, I see. Got it.
When you hold capabilities, you're holding it in struct cred.
Got it. Okay.
So in Windows terminology, it would be as a security token.
Okay.
So in NT, it would be like an NT token.
Okay.
So it contains your UID and everything you need to do security checks. So the key thing that makes this work is the capability check. So for a capability to succeed, the cred and the target namespace need to match. So here, if we look at the yellow cred in the diagram, this cred cannot succeed. If you're holding this cred and your target namespace is init user ns, that capability check cannot succeed. So I think this is kind of a fairly critical part of the security model, is that because you're in a user namespace, your privilege, so anything that your cred can do, can only be done in a matching namespace.
Okay, so if I understand correctly, does that mean like every time you do like any sort of security check, you always check which user namespace that object belongs to, and then if they mismatch, it will be a failure?
Correct. So if you look at the actual code for the check, is it still showing?
Yeah.
So all the capable stuff all eventually goes through the security modules layers, and it comes down to cap capable, and see, cap raised is only ever checked if the target namespace matches the namespace of the cred.
Okay.
So there's some additional wrinkles about levels in the hierarchy, which implement features so that if you have privilege in a higher namespace, that inherits down to a lower namespace. So
I see. So does that mean like it's not really a hierarchical relationship, because like if a privileged process in the root user namespace might not be able to access to something that's inside a child user namespace?
No, that's always that. No, so it is a hierarchical check in that sense. So that's what this level is doing here.
Oh, I see. Got it. Okay.
So these checks become a little bit subtle, I think. I haven't fully thought through exactly what they mean, because so you start at the when you're doing the access check, you're trying to find a common namespace, and you're walking up the tree. And if you're the parent and you own the parent, then it's good. If you're going down, if you end up on a lower level, then it's not good. But ultimately, the kind of logical model is that you can own the parent namespace can have privilege over child namespaces, but not the reverse.
Okay.
For anything that doesn't have that, anytime you do a capability check against something that's not namespaced, so like capsys time, for example, what happens is they specify a init user NS for their capability check, and that happens here. So capable does NS capable, and your target namespace is the init user namespace. So that means there's basically two paths for capability checks. I'm capability checking against a namespaced thing, a namespaced kernel object, in which case my namespace is I have to share a common user namespace. Or I'm capability checking against something that is not namespaced, in which case I have to hold that privilege in the user NS. Does that make sense to everybody?
Yeah, I think that makes sense.
Yep.
Okay. So now we get to the other magical part of namespaces, which is the ID mapping part. So each user namespace also contains an ID map. So the way ID mapping works is basically given by this diagram. So there's always a one-to-one mapping between each individual ID in each namespace. So we'll just talk about IDs because user and groups work the same. So basically what you have in the init user NS, you have this blue mapping. So you have all the original, you have like a full 32-bit range of UIDs. And as soon as you create a child mapping, what you're effectively doing is you're saying some specific range in my child namespace maps one-to-one with this other specific range in the parent namespace. It's always a bidirectional mapping. So if you do mapping from the parent namespace to the child namespace, and there's no mapping in the child namespace, that comes out as the overflow. Then you turn that into the overflow UID. So for shorthand, we'll just call that -1. If you're mapping from the child and there's no mapping and there's no direct correspondence to the parent namespace, again, you map to you up to -1. So there's no many-to-one mapping. You can't do things like all the UIDs in this namespace go to UID 6. That's just not a thing. So that's ID mapping. So
So James, one question. Go back to the graph you have for the ID mapping. Like the green one, like are you saying that it's okay? Like I mean, I'm trying to understand the mapping between the reddish one and the greenish one. So there's a direct mapping between these two. Is that possible too? Like I can map. Oh, I guess it's okay. It's a hierarchical. So basically, the green one is
actually, I think the green one. I think I should go back and edit this diagram because I think the arrow from the green to the blue is wrong.
Okay, so yeah, that's what I'm trying to understand. Like,
yeah, I think what would happen. I think what would happen is, I think you want to do one. I think it's only like the next way. I think it maps only to the parent. So I think what would happen, in fact, is that you would go from the green grandchild to the child in orange, and there would be no mapping, so you would get -1.
Okay. Yeah. Okay. Sounds good. Yeah, I think that makes sense.
Yeah. So mostly, in terms of how other namespaces, other containerization stuff works with namespaces, their text here is all about ID mapping, not about the security model. Because I researched it in the backwards direction. I was focused originally on the ID mapping because I didn't really understand that there was a security model behind this in the first place. So my perspective has flipped around a bit as we've gone through this exercise. There's a bunch of interesting user in Linux utils and shadow utils. So there's kind of this weird manual support for it. And if you look at the system tools, there's new UID map, new GID map, and a bunch of files called in sub-UID. So etc. So you have sub-UID and sub-GID. sub-UID and sub-GID, basically what they're for is they're to arbitrate access to an unused block of IDs in the parent namespace. So imagine you had multiple containerizers and they all want to run user namespaces and have ID mappings. Well, how do you make sure that they actually own the ID mappings in the parent namespace? Well, you can specify it all in sub-UID. And that's what new ID map does. So new ID map basically looks up your UID in sub-UID and sub-GID, and it installs the corresponding ID mapping range.
So James, just one clarification question. So that new UID map is a tool that modify, like, does it look into some configuration file?
Yeah, so the configuration file it's looking at is sub-UID and sub-GID.
Okay, I see. And then get a range from that thing. And the size of the range is fixed?
The size of the range is specified. No, it's not fixed. It's specified in sub-GID. So
Okay.
if you look in, so sub-UID has the logical name. So this is like who owns the range. Then it has the subordinate user ID, subordinate user ID count.
Okay. And then you update the UID map in the proc of that process?
Yes.
Okay. Okay.
So let me just check. Let me just look at my machine. Yeah. So basically, it's the two numbers. It's the start of the range and the size of the range.
Mm-hmm.
So let me just paste it. So on my system, stupid screen, it looks like this. Can you see that?
No, we cannot see the terminal.
Oh, can you see what I pasted into the browser?
Yeah, I can see the browser.
Okay. Mine is pretty slow.
Okay. Can you see that? It's so Etsy sub-UID for me says that Docker root starts at UID 100,000 and it has a 64K range. And I have Zookeeper, Darby. So Shadow Utils, when it creates an account nowadays, Shadow Utils also puts an entry in sub-UID and sub-GID for 65K, and it allocates 65K blocks for each system user. So that's kind of a sorry, go ahead.
So the question is, like, what's the name on the left? Is that a username?
Yeah, so that's the username that is assigned, to whom this block has been assigned.
Okay.
So by default, for example, when Docker enables user namespaces, it looks up sub-UID for the name Docker root.
Okay,
and
so who config that map? Is operator config that map?
It's for the operator, but Shadow Utils has been updated, so Shadow Utils automatically populates it.
Okay, so that's the new GID UID mapping command.
Yeah.
Okay.
So that's basic. So this is basically saying we've reserved this range of IDs in the root user namespace for you to map things to.
Okay, then who's gonna do the actual mapping? Like, say, okay, I guess for Docker, you just read this file and then find out the mapping for that given user and then assign the corresponding UID mapping.
Yeah. Also, so for how you use this thing is completely sort of arbitrary. And in fact, I think historically a lot of it comes from LXC. So what LXC does, so in LXC you have a config. LXC containers work sort of like VMs. Like the model seems to be more like a VM-based model. You start a container and it's kind of long, this thing you have for a while. So you have a container conf which specifies the configuration for the container you want to start, and you have a specific option for the ID mapping. And basically you have it twice. You do it one for your UID, one for your GID, and LXC checks the sub-UID files to ensure that the mappings you request are contained within the mappings that you're allowed to have as defined by sub-UID and sub-GID. Does that make sense?
Yes. Okay, that makes sense.
So LXC isn't using sub-UID and sub-GID as configuration. It's saying it's using it as arbitration, right? Saying, oh, you have to have it. You have to have you can do what you want, and we're not going to like worry about it. It's up to you how you think this thing should work, but you're only allowed to use the things that your admin has. You're only allowed to use the ranges that your admin says you can use.
Okay. So do you know if LXC actually, like for the root file system, like once there's some mapping is specifying the container.config, and based on that configuration, does it change the root file system to match that mapping? Like, so for example, like making sure that it's change on in the root namespace to be the start of that range, so that it will map to 0 for those files.
Yeah, I think it does. I don't remember the code for that, but I'm moderately sure that it does.
Okay.
I spent a bunch of time with systemd code, and systemd definitely does.
Okay.
But systemd completely ignores all the sub-UID and sub-GID files. So what systemd does is, so notice how LXC lets you basically define your mappings. So, oh, you can have this thing. This is what I want. Systemd generally just models everything as a 64K range. So you do private users, and systemd will try to wisely choose the start of the range based on a bunch of stuff. But basically it goes, your UIDs and your GIDs start at the same point, and they're all 64K.
Mm-hmm. Okay.
I say 16K, I probably meant 64K. So basically it models it as a start and a shift. So that's a bit of a performance trick that they use, because they actually go through and chmod everything when they construct the root feed.
I see. Okay.
Rocket pretty much defers to systemd and spawn. So for our purposes, Rocket, systemd, and spawn are the same. Docker is sort of this. Docker is this little bit of a middle ground between what LXC does and what systemd does. So with Docker namespaces, you specify user namespace globally on the Docker daemon, which is kind of an interesting choice. The reasons why they do that is because if once they do this, because they don't want to do the chmodding from some arbitrary file permission from whatever the container was unpacked to into some arbitrary user namespace mapping.
Yeah, I was thinking about that. Is that equivalent to like running Docker daemon inside its own user namespace?
Is it equivalent to that? No.
Like, for example, like I imagine, like, say, if you run Docker daemon not in the root user namespace, but in a child user namespace, and then all the files you download is going to be mapped to UID 0 in that user namespace, but it maps to different user on the root namespace. And then you launch container in that user namespace. That means all the container that Docker daemon launches it's going to be unprivileged in the root user namespace. Is that equivalent to that, or it's kind of slightly different?
It's really, really close to that. So that's mostly what they do, but they're not running, as far as I can tell, they're not running the Docker daemon itself in a child user namespace. Because if you think about the privilege model we spoke about before,
mm-hmm.
you can't contain it. You can't set up things correctly.
Yeah, I think there is something that you have to be privileged inside root user namespace. I remember there's some
exactly. But they do definitely download and do all the image downloading and image staging within the global child user namespace mapping.
Got it.
And they do that for exactly the reason you're talking about, because it means that they just download it and everything, because they're writing files within the context of that child namespace mapping, all the mapping permissions are automatically correct for all time.
Mm-hmm.
And so it's kind of an interesting. It's a fairly interesting choice. But
can you hear me?
Yes. Yeah, we can hear you.
So does it mean that they're using a binary or subprocess to do that all the polling provisioning thing?
I was not able to find the code. I didn't spend too much time looking for the actual code, but it probably makes sense since Docker's in Go. It probably makes sense that they fork or something.
So that's actually, well, at least architecturally a little bit different than ours, right? So because we do polling.
Yeah, initially, like the reason I mentioned this is because I was thinking about that user namespace thing, and one option to me is like, why not just run an agent inside its own user namespace and its privilege inside that user namespace, and all the files it downloads is gonna be under UID 0 inside that user namespace, but it's gonna be unprivileged outside.
Mm-hmm.
So that's one option. But I realized that there are some C group issues that you cannot do in a child user namespace.
There's kind of lots of things as well. So,
yeah,
so
and
also,
making node, it's not going to work, I think.
Yeah, and also the critical thing also is that here with Docker, it's not a goal for their implementation. It's not their goal to protect containers from each other. Right?
Yeah. The other kind of idea I have, maybe we should go through the thing is, but I can't just mention here is things that we have. The user namespace has two things, like the privilege, like capability check part, like and the UID and GID mapping part. Like, is it possible to do just one part, not the UID GID part? Like, I think even doing that is still valuable to us.
Yeah, I agree. And that the way I'm thinking of progressing right now is to tackle the security model part of it. So get into a user namespace, but retain the global mapping. So everybody still has the same, like has a one-to-one mapping. So each child namespace maps the full range of UIDs to the parent namespace. So 0 to 232. But we just keep it exactly the same ID mapping semantics that we have today, but we leverage user namespaces to create encapsulated security domains for containers.
Right. So I think I think that's something I want to explore. Like if we can do the security part of the user namespace, that would be still valuable for us in many of the cases. And the file system part, like UID, GID part, so that part we have some level of protection.
You faded out there.
Action using file system isolation or something like this.
Right. Yep. So I think that's, I agree. That's very similar to what I was thinking about. I dug through Kubernetes, through their issue tracker and things like that. There's a bunch of proposals. There were some proposals and there was some activity. It seems to have died down a bit. What it supports now is it detects that whether the corresponding Docker is running with user namespaces enabled, and it turns off features which aren't supported. Basically, what they're trying to do is anything that depends on the host environment gets disabled if you're running in user namespace. It's a little bit weird. I don't think there's a technical reason to doing that. I believe it's more related to internal Docker implementation issues. Finally, in the OCR runtime spec, OCR runtime lets you specify these things, but it doesn't tell you what to do with them. It doesn't make any mention of the semantics of what you're actually supposed to do. Right? So you can specify an ID map and GID mappings in the OCR runtime, but it's sort of pointless because what does it mean? How should I handle it? Or who knows? It just doesn't. I don't really see how it makes that much sense.
So sorry, I was dropped. So James, so one question on OCI. So they allow you to specify the mapping, and they don't say anything about the reference, because I think they just assume the reference is there.
their reference. Sorry, can you rephrase that?
Yeah, I'm asking for the OCI support right now for the user namespace. So what about the rootfs for the OCI container? Do they need to change the owner, or like they just rely on like top level application to do that?
They don't say. They don't tell you what you're supposed to do with it. I don't really understand why it's there. It seems kind of superfluous. It's just basically like it's literally that their spec is literally like, here are some mappings. Like, are you supposed to do anything with it? Who knows? What are you supposed like? What is the goal of this thing? Like, who knows? I mean, I don't really understand.
Yeah,
I don't really understand what the intention is by having these things in the runtime spec. This doesn't seem relevant to anything.
Yeah, I think it's mainly just like I have this configuration, the runtime should just config the mapping according to that configuration. How do you set this configuration is totally up to the top level application that use that runtime.
Right, but it's kind of nuts, right? Like how is I mean, you're specifying some arbitrary container and you say, well, I want this to start with some offset on the host. Well, how would you know that?
So this one, I mean, this config is not directly exposed to user. It's supposed to be used by something like Mesos or Kubernetes to directly use those things, like use that primitive to config their containers. And the way you specify those ID and range depends on the way you want to do the user namespace. I think that's my understanding.
Yeah. So
right. Actually, I think this part is more like OCI doesn't even create the root file system for you. So like the orchestration part before the container happens, the provisioning part, actually it's supposed to take care of that and then inject all those things as the parameters. That's also my understanding. Yeah, this is Jason, by the way.
Hey, Jason. So yeah, I couldn't figure out whether the OCI was just like it was just obvious or useful. But it's not, for our context, for the context of this, it doesn't really do anything, right? It just says, here's the knobs. Well, okay, we have the knobs, and yeah, we can express them in the OCI JSON, which is fine, but it's not really helpful.
Yeah, I think that it will be interesting. Like, do you have a kind of sense, like in the discussion of the Kubernetes community on user namespace, what's the main issue that they kind of prevent them from like finish that? Like, what's the main blocker?
It just looked like people went away. So there was a lot of activity, a lot of discussion about some specific patches, and then the people who are interested in it kind of went away, and that was it. And the issue got closed.
I see. Yeah, I think we have the similar issue. Like, I think some IBM folks show up like I think a year ago or so that on this, and kind of the suggestion I give to them is I think they're trying to do the UID GID mapping right away, but kind of a suggestion I give at the time is like maybe like the UID GID mapping has a lot of issues given that like you have to change owner and deal with volumes. Yeah, it's not that straightforward. Like, I don't see how easy it is to do that without like some functionality from the current like UID GID mapping shift, things like this.
Yeah, the shift FS. I looked at the kernel discussions for shift FS and stuff like that. It doesn't, and that's not going anywhere anytime soon.
Okay, I see.
But none of the file systems people are very happy at all with the way shift FS was done, and there's been a couple of approaches, but it doesn't seem like none of that seems like really promising.
Can I inject some thoughts? So I think in here, there are some file systems does them like allow you to do some like UID and GID setup in their file system mount options, and then like with that we can actually do the translation, the UID GID translation from the mount file system, but that doesn't seem like the most viable solution. More or less like a hack and relying on file system implementation.
Which file systems do you have in mind there, Jason?
Yeah,
I think does NFS support that?
Yeah, NFS does, but that's not. It's kind of. I mean, that's over the wire, though.
Yeah, so I think I know like NFS has this functionality that you can specify different UID, GID when you mount.
It's available also in other file system like mount options, but it's really dependent on the exact implementation. Maybe there are like some kernel level of mapping needed. So for example, something like a fuse file system, and then do the mapping for you, and then with better ACL control and stuff like that. But
So yeah, with Fuse you can do everything, I think.
Yeah, I mean, this is sort of a long-standing thing in the network file systems space, because in network file systems you're connecting to different domains which have different identity, different sources of identity and different directory services, and that's why kind of ID mapping comes out of the network file system space. So you could probably wire stuff up with network file systems.
Okay,
it's not all that general.
So James, I have another question. So regarding nesting, have you thought about this? Like, how do you enter? Is it like what's the way of entering a user namespace? Is that still like setNS?
Yeah, it's still setNS. But if we go back to this diagram of the hierarchy, we need to be really careful, and we need to think hard about what our security model is when we create these namespaces, because we want to make sure that we have our other namespaces parented at the correct layer in the hierarchy, depending on what we're trying to do, right?
So does that mean like we have to clone user namespace first before we clone the namespace?
Yes, if we want the PID namespace to be owned, we want the PID namespace to be a child of the container's user namespace, then we have to enter the user namespace first and then the PID namespace. So the ordering matters to construct the tree for the security model that we're trying to enforce.
Okay, so but how does that affect the clone system call? Right now you can specify like what are the namespace you want to join in a single clone syscall, like, and you specify those flags. Like does the order inside the flag matters? Or?
I think that sysclone does the ordering the way you want.
Oh, okay, that's good. Yeah.
I don't know if it's documented or whether it's.
So what's going to happen if you specify user namespace last in the same call?
I think it's a unordered like bit mask, right? So I think depends on what the actual system call is being handled in the kernel. If the kernel always handle user namespace first based on the mask, then it shouldn't be an issue. I guess one thing you cannot do is like you clone the PID namespace first and then do a share on user namespace. That's not going to work, because that will put the PID namespace outside that user namespace.
Yeah. So and it depends whether we're trying to build a container with like some privilege or least privilege. So what I'm probably eventually going to propose for least privilege is that we place the final tasks in an additional layer of user namespace, which doesn't have any of the other PID namespaces attached to it.
Sorry, can you say it again? Like explain a little more.
So if you look at the diagram, we have two layers here. We have three layers here. We have init, then we have some arbitrary layer, then we have a leaf node user namespace, which has PID namespaces and whatever attached to it. If we want to run an unprivileged task in a container, what I'm thinking of proposing is that we create a user namespace for the task group, and that contains our whatever we construct. That contains the environment for our container. But when we run the task itself, we create an additional child namespace, an additional child user namespace to create an additional level in the security domain hierarchy. And that'll be our new leaf, and that leaf won't have any other namespaces attached to it.
Even if the PID namespace is not attached to that leaf user namespace?
Correct. So the PID namespace, so that when we clone things, you'll still be in the PID namespace of the grandparent user namespace, which means that even if you're able to obtain privilege to your user namespace, you still can't have privilege again. You still can't do privilege operations against your PID namespace because its parent is your grandparent.
Yeah, but one issue I saw is like this is okay for 2 levels. What about like you want to have 3 levels? Like, does that still work? I mean,
Yeah, you can have 3 levels.
But can you have a nested PID namespace even if that the parent PID namespace is not inside, not of the same user namespace? Does that still work?
Yeah.
Oh, okay.
I'm pretty sure that works.
Okay.
Like you don't like all your namespaces. The namespaces for a task don't have to all be at the same user namespace level.
Got it.
Like some of your namespaces can be at your level, and some can be at the parent level.
Yeah, I think what really matters is just user namespace and PID namespace because these are the only 2 that is kind of hierarchical. The rest is not like hierarchical.
No, they're all hierarchical.
Well, I mean, okay, but you don't have a kind of really okay. For example, like narrow namespace. Narrow namespace is not hierarchical. Like you don't have a parent narrow namespace concept.
Oh, sorry, but it's hierarchical in the security model. So it has a network namespace still has a parent user namespace.
Oh yeah, so user namespace itself is hierarchical. So you do have a concept of like a parent user namespace. I think narrow namespace has a given user namespace attached to that narrow namespace, but narrow namespace itself is not hierarchical. So there's no parent narrow namespace.
Oh, right. Yeah.
But PID namespace does have a parent PID namespace. Okay.
Yeah. So it's hierarchical. So the network is still part of the security model hierarchy, but it's not. But there's no separate network namespace hierarchy.
Yes.
Okay.
So do you have anything more? Okay.
It keeps going forever. As some chit chat about use cases. So the primary use case, I think, for us is we run, in our containers, people, for practical purposes, we consider containers to be running untrusted code. So we feel we want to approach the problem as if we're running arbitrary crap off the internet. So we want to make sure that we want to make these containers as secure as possible. We want to be proactive about defense in depth and making sure that you can't do some kind of privilege elevation from a container that would affect the host or affect other containers. This is sort of a subset. I have a consistent user inside a container. I want to map that to some kind of user on the host that's controlled by a cluster operator. So the context here is, say you go tell your users, hey, all your containers should run as user free, and as an operator, I want to make sure that user free maps to some specific user on my host. So I want to make sure that user free maps to unprivileged free, so I can have some sort of guarantee about what a user mapping is going to be. So I can do something about making sure that that is unprivileged, not only in the security model sense, but also that in the file system permission sense.
Hey James, this is slightly orthogonal and probably is coming from my lack of knowledge in this whole space. But I felt like one of the main user space is to kind of block or isolate the access to volumes, which probably is pretty important over here. So does this have any impact on CSI as such? Like the way CSI actually does volume and resource management right now, does it actually need to map to, I don't know, cluster-wide users and has to do something with the user namespace of the container?
Oh yeah.
Volumes are going to be a huge mess. Volumes are going to be a big mess. The Docker doesn't do anything about volumes with this, but because Docker ensures that all tasks on a specific host because Docker only has one UID mapping for all tasks on a specific host, volumes are going to work consistently.
Yeah, but CSI doesn't work that way, right? So
it depends on what we do. I think that's the challenge part. That's the reason like usernames is not done in Kubernetes on Mesos. It's because this volume thing.
So as soon as you have cluster volumes where you could have different mappings you could have it basically per host mappings, or as soon as you allow like different containers on a host to have different mappings, then yeah, it's kind of a world of complexity.
Yeah, I think that's the reason, like initially, like I think we have the volume ownership and access control discussion previously. I was trying to see if there's a way to decouple the volume access control from the UID, GID thing. So that's one way, but I'm not sure if it's going to work. But there's some other ways.
Yeah, ultimately, network and cluster file systems really depend on there being a shared identity service for access control.
Yeah. So the reason I'm raising this question is like whatever decision we make on how we implement the UID GID mappings within a container, I would say we should really take into account how CSI would work with it. If it doesn't, then it's a no-go, because I mean CSI becoming a central component of the way storage works with Mesos and Kubernetes, it'll cause a lot of problems down the road then.
Yeah.
Right?
Yeah, I think so. That's the reason initially I suggest that we probably don't tackle the ID mapping part initially. At least the first use case that James mentioned, that we don't require like strict ID mapping.
Got it. Yeah.
Just you make sure that you're not privileged inside your container. Yes. You cannot do something like a make node or something.
I don't think CSI I don't think, as far as I know, CSI per se doesn't make this any more or less. It doesn't really affect the problem. It's just a generic problem about how you do ID mapping with storage.
Right. Yeah. It's a general.
Is there anything specific about the way CSI deals with storage that?
No, I think right now, like CSI don't dictate anything. It's totally up to the container runtime to decide what to do about volume ownership. Mm-hmm. Some plugin, like CSI plugin, might have some like ID or ID mapping concept. For example, I can totally imagine some Fuse plugin can have something related to that, but CSI itself does not dictate any of those.
Yeah. So that's kind of why I spent a bit of time on the security model, because I think that the security model is a benefit independent of the ID mapping.
Yeah, I agree. So I think we are on the same page. Yeah. I think that's kind of the suggestion I gave to IBM folks initially when they start to approach this problem, because I think UID GID mapping is a mess. Yeah. Kernel don't have a good solution for that yet, and I don't think we can have a good solution.
But one place where potentially you want the ID mapping is this use case where you want the process inside the container to be able to have privilege within the container. So you say, I want to run a container, and I don't want to run like just some arbitrary task. I want to run a privileged task in there. So once you're running, if you have a shared mapping between all your containers, if say you use the host mapping for all your containers, the host ID space, and you let a task inside a container have privilege, then that allows privilege escalation.
Like, yeah, I'm curious, like, how do they do that if they have their own file system, and then you make sure they don't have like special volumes that from the host?
If there's no way out of the file system, then it's fine if you can guarantee that. But if that container can like leave files behind, it can, as soon as you allow this, if you're using the host ID map and you have inside a privileged container, then the privileged container can create a file that's owned by root and has set UID, and then maybe there's some other side channel that could allow it to execute that in a different context, and you can privilege escalate from there.
Yeah. So assuming there's no like a hole inside the file system in that for that container, then it should be. I mean, unless you have some bug in the kernel or like there's some special way of doing privilege escalation to bypass this file system sandbox.
Right, but then you have shared file systems, and one privileged component can lay down something that can be picked up by some it's.
But the file system itself is dedicated for that container, right? No matter what you modify, it's going to be part of that container. Unless you share something with other container or share with the host, like you mount a host volume, then you're going to be in an issue because you can write files. Or you can just do by mount of like etc password. It will be on the host, then it will be a security issue.
Yeah. So But that's the question: is if you allow this, can you guarantee that? Like, how do you guarantee that the files are contained?
First of all, I think we should disallow host volume. That's evil. And I think if you want to be more secure, you should ask the container to use a container image and don't have host volume. As long as you have these two, I think it should be okay, unless I missed something that it might get escalated using.
Yeah. So we might better do that.
I think host volume is evil anyway, so we should disallow that anyway, because you can just find on etc password, which.
Finally, I think one of the goals, one of the use cases is I want to run something that just doesn't use user namespaces, because we have lots of. I'm sure we have lots of existing cases where we run tasks that don't need any of this stuff, and we're applying this stuff with break tasks. So we want to be able. We want to. It's not something that I feel we can enable by default in the agent, for example.
Yeah, we can always make
it has to be opted.
So it has to be an API level thing.
Yeah.
Okay.
So we only have 5 minutes left, so I don't want to go and start anything more. But the rest of this sort of discusses specific things about, how do I think this works in Mesos, and what is the impact going to be? Do I think it's a little bit more hand-wavy? It's just trying to capture areas of the code and areas of the code base which are going to be affected by these sorts of changes.
Okay, so maybe like we use this last 5 minutes, like what's the next step on this? I think as we discussed, like I think we kind of both agree that maybe we don't tackle the UID mapping part, tackle the security model of the user namespace. I think that should be totally doable. That does not satisfy all your use cases, but satisfy a few use cases, I think.
Yeah. So my next steps is to explore the more concrete aspects of actually getting into a user namespace. I also been tasked to explore getting into a user namespace without actually doing the mapping to the host ID map. So one of the reasons why you have a map, basically in a Docker container, you want root files to show up as root, right? But I need to explore how bad it would be, or what it would be like if files that were owned by root in the container just showed up as -1, right? Maybe it's just cosmetically ugly, and we just don't care. And as an operator, I just might not care. So I think trying to explore what that behavior is.
Okay, that sounds good. Mapping to -1 is interesting. Like, what do you mean by mapping to -1?
Well, it's shorthand. It maps to the overflow UID.
Oh, okay.
The overflow UID is 6.5 is basically it's -2 in uint16 for NFS historical reasons. Because all this ID mapping comes from NFS, and NFS used to have 16-bit UIDs across the wire, and if you didn't know the mapping, it would give you back -2.
Okay, interesting. Okay. All right, thanks for presenting, and this is super useful for me, and I think for other folks too, I think. I think we have a kind of next step, and let me know if you want to discuss the design or something like this in the future. Yeah, willing to help on this.
Cool. Thanks.
All right, thanks everyone, and I think that's it for today, and see you guys in 2 weeks. I hope the next time we can go into that VM discussion. I think we saw the doc being populated by someone on a few items. I still need to populate my part, and some of the folks, yeah, I'll ping the rest of the folks so that we can have a kind of the background introduction for VM supporting Mesos next time. All right, thank you guys. See you guys in 2 weeks.
All right.
Bye-bye.
Yeah. Thank you.
Thanks, James.
Thank you.